This is worksheet 15.1, and we're going to look at 10 and 11. Here we're trying to prove that this expression is not equivalent to the expression in number 9. Number 9 is telling us that this expression is equal to what we got in number 8, which is 100. So we're trying to prove that this one is not equal to this expression or a sum of 100. This notation has a few things that are important. The number at the bottom represents the starting term. Number at the top represents the end term. So if we fill in these values here, this is the starting term. This is the end term. Then in our formula here, this is an arithmetic formula. We know that this number represents the common difference, and this number represents the initial value. So in this expression, if I were to evaluate this, this is the Greek letter sigma, which represents a sum. So this is telling us to sum or add up all the answers we get, plugging n equals 0 all the way to 4. So n equals 0 gives us an expression equal to 5, plus, that's what the sigma represents, plus when n equals 1, 5 plus 5 times 1 is 10, plus when n equals 2, we get 15, and then we have n equals 3 and n equals 4, so when n equals 3, this is 20, when n equals 4, we get 25. If you were to add all these values up, 15 plus 15 is 30, plus 20 is 50, plus 25 is 75, we've just proved that that's not equal to the expression here, which we were told is equal to number 8, or 100. In number 11, we're asked to show what expression would work if we want this to be equal to the expression we got in number 8. So we want this to be equal to this series. If we're going from 0 to 4, and we want the first term in our series here to equal 10, so when n equals 0, we want the answer to be 10. We still have a common difference of 5, but if n is equal to 0 and we want our answer to be 10, this initial value would have to be 10.